Okay, so the purpose of this video is to go over the proof of the derivative of e to the x. I did this one in class, but I just kind of want to make sure that we're all set. In order to take the derivative of e to the x, the first thing I'm going to do is go ahead and remind you that this function, if you graph it, e to the h minus 1 over h, if we are to graph that function and take the limit as h approaches 0, the limit as h approaches 0 of e to the h minus 1 over h, the result of that, you can see here from the graph, is going to be 1. So we're allowed then, because we confirmed graphically that this is true, anytime we see this limit, we can actually replace that with 1. So that's going to be kind of our prep work here. Alright, so let's go ahead and take a look at the actual derivative. To do that, we're going to go back to the definition of the derivative, which says the limit as h approaches 0 of the function e to the x, but instead of e to the x, we got to do e to the x plus h minus e to the x. So again, this is the definition of the derivative. Sorry about that. H. We're going to try to work this out. Clearly right now, if we plug in a h, we're going to get a 0 in the denominator and a 0 in the numerator, which just means we have to do a little bit more work, do more math. For that, I'm going to take you back to rules of exponents. If you remember a long time ago, if you did something like a to the 3rd power times a to the 4th power, that becomes a to the 7th power. And the rule goes that a to the m times a to the n is really just a to the m plus n. So what's going to happen is you're used to starting on the left side and going to the right. We're going to start on the right and go to the left. So imagine we start with e to the x plus h. If we undo the rules of exponents, this would really show to be e to the x times e to the h. So we were saying that we're going to unpack or undo the rules of exponents, so e to the x plus h becomes e to the x times e to the h. And so what that allows us now to do is to rewrite this part as e to the x times e to the h. So that'll be the limit as h approaches 0 of e to the x times e to the h minus e to the x. And as math students, you probably already have kind of an intuition about what's about to happen. You see that there's an e to the x here and an e to the x here, so clearly we need to factor those out. So let's continue down here. We're going to take the limit as h approaches 0 of e to the x, leaving inside e to the h minus 1 all over h. And remember, a while back we saw this expression. It's the one that we looked at graphically, and we took the limit and we said, alright, anytime we find e to the h minus 1 over h and we apply the limit of 0, then that whole piece can be replaced with 1. So this whole thing becomes 1. And there are no more h's left, so once we've applied the limit, the result is e to the x. Therefore, the derivative of e to the x is itself e to the x. So in general, the way you'll see this in general is going to be d dx, so the derivative in terms of x, of e to the u is equal to e to the u times du dx. And all this means is that if u is not x, if it's 5x or 3x or anything like that, then you're going to need to do a chain rule. So let me show you an example. Let's say we had y equals e to the x squared. Its derivative would be itself e to the x squared. Very important that you leave that x squared alone. Okay, that's the inside of the function. So it's going to be the derivative of the outside, that's e, leaving the inside alone, times the derivative of the inside, which is 2x. So that's it. It would be y prime equals 2x e times e to the x squared. And that's how you would find this derivative.